Hi viewers, in this video I am going to explain the calculation, that means the numericals on chemical equations. That means calculating the volume, mass, number of molecules involved in the chemical reaction. So mass, volume, number of numerical molecules. So in this question given for the hydrogen, number of molecules for hydrogen liberated when 230 grams of sodium reacts with 1 second excess of water, means the water molecule. Let me write the equation first. Sodium Na reacting with hydrogen H2O, that means water. H2 is liberated, so H2 liberated, this is liberation symbol. NaOH, product is sodium hydroxide NaOH. So H2 liberated from water. So for balancing I am writing 2 for H2, and here 2 plus 1, here it is 3. So if I write here 2, then that will become 4. 2 hydrogens and there 2 hydrogens, here 4, 2 to the 4, here 2 plus 2, 4. If I write 2 for sodium, then it will be balanced. 2 sodiums, 2 oxygens and 4 hydrogens. So now this is balanced equation. I am writing with the formula units. 2 sodium formula unit is 23, so 2 into 23 plus 2 into H2 means 2 into hydrogen is 1 plus oxygen is 16. Gives rise to 2 into again sodium 23 plus 16 plus 1 plus hydrogen here 2, so 2 into 1 here 46, 2 into 23 plus 2 into 2 plus 8, 16 is 18. 2 times of 23 plus 16 plus 1 is 40. 2 into 40 plus here 2. So if I write in the grams, 46 grams of sodium plus 2 into 18 is 36. So 36 for water. 36 of water, that means 36 grams. Gives rise to, this is 36 grams of water, gives rise to 80 grams of sodium hydroxide NaOH plus 2 grams of H2, that means hydrogen. So hydrogen we got only 2 grams. When means is asking, we got as 46 grams of sodium, is asking for 230 grams of sodium. So first we'll calculate the mass, that means in the grams. Question now of sodium, see 46 grams of sodium gives, asking for sodium and hydrogen, so we'll consider only this one, gives how many grams of hydrogen is 2 grams of hydrogen. Is asking for 230 grams of sodium. So when 230 grams of sodium is taken into consideration, it gives how many grams of hydrogen. That is, we take it as x. We will cross multiply this one. Then x equal to 230 grams into 2 grams by 46 grams. 2 ones, 2 23s, 23 ones and 23 tens. So x we get as 10 grams of hydrogen. That is, mass of the hydrogen is 10 grams. When means it is reacting with 230 grams of sodium with water. We get 10 grams of hydrogen. Okay. Now coming to volume. Clearly mentioned STP. STP means standard temperature and standard pressure. So standard temperature value is 273 Kelvin or else 0 degrees centigrade. Now standard pressure is nothing but 1 atmosphere pressure. So at these values volume will be 22.4 liters. 22.4 liters volume. So now 2 grams of hydrogen occupies at STP said, so occupies 22.4 liters of volume. We got the mass as 10 grams. So at 10 grams of hydrogen occupies how many liters of volume? Again cross multiplication. How? See, x equal to 10 into 22.4 by 2. 2 ones, 2 fives. So 5 into 22.4 we get as 112.0 liters. That is 112 liters of volume hydrogen occupies for 10 grams of mass. Then number of molecules now. Number of molecules, how to find? According to the Avogadro number n suffix a, 6.02 into 10 to the power of 23 molecules. That is 1 mole equal to 6.02 into 10 to the power of 23 molecules. Okay, so 2 grams of hydrogen. 2 grams of hydrogen is nothing but here 1 mole. 1 mole of hydrogen occupies 6.02 into 10 to the power of 23 molecules. Then now 10 grams of hydrogen, how many number of molecules? Cross multiply 10 into 6.02 into 10 to the power of 23 by 2. 2 ones, 2 fives. So 5 into 6 is 30. 30.10 we get into 10 to the power of 23. If you reduce this one, right, in the standard form, so you will get 3.01 into 10 to the power of 1 decimal form is changed, so this will become 10 to the power of 24 molecules. So 10 grams of hydrogen gives 3.01 into 10 to the power of 24 molecules. This is the number of molecules according to the question. I hope you understood. Here I am taking one more example. 2 moles question. 2 moles of zinc Zn reacts with a cupric chloride solution containing 6.023 into 10 to the power of 22 formula units of CuCl2 cupric chloride. Calculate the moles of the copper obtained. So moles, asking to calculate the moles. First we will write the equation. Zinc reacting with cupric chloride CuCl2, we get zinc chloride ZnCl2 plus copper is separated Cu. Values formula units is Zn is 65 formula units, copper is 63.5 formula units, then chlorine is, we know, 35.5 formula units. Okay, so cupric chloride value CuCl2 will take, CuCl2 is 63.5, that is copper, plus 2 times of chlorine is 35.5, that is 63.5 plus 71, which is nothing but 134.5 formula units. So zinc and copper. So we'll take zinc, that is 1 mole of zinc plus 1 mole of cupric chloride gives rise to 1 mole of copper. Directly we are going with copper, not with the zinc chloride. Okay, so it's asking for 2 moles. If the 1 mole value it is cupric chloride is 134.5, so we will find out 2 moles of zinc when it is reacting. 2 moles of zinc plus 6.023 into 10 to the power of 23 is 1 mole. So here he is asking 6.023 into 10 to the power of 22, that is 1 by 10th mole, that is 0.1 mole. So 0.1 mole of CuCl2 gives rise to how many moles of copper? Cross multiply. So X equal to, here 2 moles of, before this one 2 moles of zinc means 2 into 65, plus here 0.1 into 134.5 goes to X. Okay. So now cupric chloride, we take cupric chloride, this value will become 13.45. 0.1 into 134.5 is 13.45. Then 134.5 grams if you take of cupric chloride CuCl2 gives how many grams of copper? Means 63.5 grams of copper. Now how many grams of copper we get now? For 13.45 into 63.5, this is X, cross multiplication, 63.5 into 13.45 by this one 134.5, this one is 10 times, then this will become 6.35 grams of copper, which is nothing but 0.1 mole. If 1 mole occupies 63.5, if it is 36.35, decimal place is decreased, changed, so this will become 0.1 mole. So 0.1 mole of copper obtained from 2 moles of zinc and 0.1 mole of cupric chloride. So answer is 0.1 mole of copper. Calculate the moles of the copper obtained. So we got as 0.1 mole. I hope you understood.